Welcome. And in this lesson, we're going to talk about web services as they relate to storage and content delivery and are required for our CSA training. First, let's talk about one of the core components or core services from Amazon Web Services. This is the Simple Storage Service. Amazon S3 is an object storage service from Amazon Web Services and can not only serve objects through a CDN using our CloudFront service, manage access to specific objects, allow versioning and lifecycle policies, but it can also serve static HTML files with Route 53. It's a simple key value store designed for unlimited object storage. So a little bit about this service. It's basically an infinitely scalable static hosting solution. We can use it to store files for our enterprise. We can back up our software. We can back up our files in our enterprise. And we can act as a static website hosting solution. We can fail over for some reason our highly available web application goes down. We can fail over to static HTML page. Or if you have a website that serves just static HTML files or just static files, you can use that instead of even needing EC2 instances. It's an infinitely scalable and highly available solution because all of the objects stored inside of S3 are synchronized across all of the availability zones within your designated region. So Amazon S3 is designed for 11 nines durability and 99.99% availability. At minimum, 99.99% of the time, your objects are guaranteed to be accessible and available to you. However, there's 11 nines durability, which is unprecedented for object durability. You don't have to worry about an object being lost or an object going corrupt. Amazon S3 charges based off of per gig storage, as well as data sent out of the region. However, data transfer from S3 to an EC2 instance within the same region does not cost. So we could even set up S3 to act as our file system store to an EC2 instance. And of course, one of the key components of a properly architected application is as it scales, costs decrease. So as the more storage you use on Amazon S3, the less it starts to cost. S3 objects can be encrypted using the S3 encryption option, as well as data sent to and from endpoints using the API are encrypted using the HTTPS protocol. Most commonly used for file storage, we can also use it as a hybrid solution when used with the AWS Service Storage Gateway. We can deliver static content, backups, and archive our data with Amazon Glacier. Bucket names are unique across the entire S3 design, which means regardless of the region, only one bucket can exist with the same name. If I have the bucket Linux Academy, nobody else in the entire AWS ecosystem on any AWS region can also have that bucket name. They're like domain names. Once you register one, that domain name is no longer available. So with Amazon S3, we talked a little bit about the standard storage type. It has 11 nines durability, 99.99% availability. When you upload an object, by default, it's going to have the standard storage type. However, we can specify a different storage type if we choose the reduced redundancy storage. So what is reduced redundancy storage? Reduced redundancy storage costs substantially less to store data. It has 99.99% durability versus 11 nines durability, which means that it's not as redundant. It doesn't have the durability. The object could be lost or corrupt. However, if the object is for some reason lost or corrupt, AWS will send us a notification. So we only want to use the reduced redundancy storage type for data that can be easily reproducible, or in other words, data that can be automated. So for example, let's say that we have a video transcoding service. A user uploads the source video to an S3 bucket. Now, since the source video we can't lose because we can't reproduce it, we'll want to store that on a standard storage type. However, our service automatically takes that video, runs it through the Elastic transcoder, and transcodes it into 5 different formats. Well, those videos can be automated. We can reproduce those videos through automation because we have the source video. So those 5 other transcoded videos, we can reduce our costs by storing those inside of reduced redundancy storage. If one object becomes undurable or the durability fails and the object is lost, Amazon S3 will send us a notification through simple notification service, and we can automate the recreation of that with the Amazon command line interface or an Amazon SDK. Again, these are concepts we will drill in and focus on later in this course. We're just trying to plant some seeds in your head about high availability and really how architecting on Amazon works. We need to think automation. We need to think cost-effective design, reduce costs when possible. So that leads me into lifecycle policies and object versioning. Lifecycle policies and object versioning, one thing that we need to know is that we need to pay for each versioned object. What is a versioned object? If versioning is enabled on a bucket, that means if we were to delete the object, the most recent version or any prior version would also be stored. It's a backup solution. If we rewrite over an object, it'll automatically keep the prior version. And it'll keep as many versions until we start deleting those versions. And so it's a backup solution. If you have an employee who overwrites your document and you need to go back 6 months out and you keep versions of that, you'll have those every single version of the document that's been created in S3. So we can have unlimited versions. And of course, we need to enable it on an S3 bucket. But let's say that we only want to store 2 months of versions as part of our backup policy. Then we want to automatically remove or delete all of those versions of the object that are greater than 2 months old. Well, that's where lifecycle policies come into play. We can specify inside of an AWS S3 bucket that all versions of an object are removed after 2 months. Or an object itself and all the versions can be removed after 2 months. Or we can archive it. All versions that are 2 months old or all objects that are 2 months old in our bucket, either one, we can automatically send to Amazon Glacier, which is another Amazon service, for archiving purposes. So that leads me into Amazon Glacier. What is Amazon Glacier? Well, it's considered the archival storage type. We only want to use that for data that is not frequently accessed. So in other words, if we have a job requirement, a business requirement to maintain backups for 2 months and then archive a year worth of data, then 2 months of our objects need to be stored in Amazon S3. But we could create an Amazon S3 lifecycle policy that states any object that's greater than 2 months put into Amazon Glacier for archiving. Amazon S3 is easily accessible data, so if we have a disaster, we can pull that data from our backups, our S3 buckets, in a matter of minutes. Versus Glacier, we have to check in and check out jobs, which can take up to a day. So if we need to store data for 10 years for financial reporting purposes, but it doesn't need to be easily accessible, we would use Amazon Glacier. So that integrates heavily with Amazon S3 lifecycle policies, and we'll take a look at that hands-on more in our Amazon S3 section. Amazon Storage Gateway integrates very well with Amazon S3 and is really kind of considered to be a hybrid solution. It integrates with our local data center or on-premise software appliances to our cloud-based storage on Amazon S3. There's 2 ways to set up Amazon Storage Gateway. We can set up a gateway cached volume or a gateway stored volume. So a gateway cached volume, what you do there is on-premise, you would create a storage volume and mount it as an iSCSI device on the on-premise server. And what happens is our gateway configuration from our on-premise server to Amazon S3 will store the data written to our on-premise storage mount inside of Amazon S3. So if we were to write a document, save a document, a Word document, a PDF document on this storage device, the storage on-premise server in conjunction with Amazon Storage Gateway would then synchronize that or upload it to Amazon S3. The storage gateway and a gateway cached volume would only maintain a copy of frequently accessed data on the on-premise storage device. So as to reduce costs, if we have a document that's accessed frequently, we don't want to send it back and forth to Amazon S3 every time we need to access it. Instead, we want to reduce latency and access times by storing it cached locally and then synchronizing it back to Amazon S3. And so that is gateway cached volumes. So gateway stored volumes is more of a backup solution to Amazon S3. So all data, regardless of anything, all data is stored locally in our on-premise appliance inside of a storage volume. It is connected with Amazon Storage Gateway, And Storage Gateway will periodically take snapshots of the data as incremental backups and store them on Amazon S3. So all of the data is stored locally. It is accessed locally. It is updated locally. Amazon Gateway stored volumes will take snapshots of our local storage and upload it to Amazon S3. So again, this is a backup or disaster recovery solution. Whereas our Gateway cached volumes act as a cloud-based storage solution. So we don't have to have as much storage space locally if we're using the cloud, using Gateway cached volumes. And the last storage service I want to talk about is Amazon Import Export. So what is Amazon Import Export? So the last service I want to talk to you about is Amazon Import Export. Amazon Import Export gives the ability to take on-premise data and physically snail mail it to Amazon Web Services. So you could take a hard drive, store your on-premise data on there, and physically mail it to Amazon Web Services. AWS will then import the data into either Amazon S3 or an EBS volume or Amazon Glacier. And it will do it within 1 business day of the physical device arriving at Amazon Web Services. So what are some benefits of this? You can quickly provide off-site backup policy. You can take a physical device and ship it to Amazon Web Services. That is a backup policy. You can quickly migrate large amounts of data to the cloud, and you can use it for disaster recovery. So if you were to send data as a backup, Amazon can even take the data that's currently on Amazon S3 and ship it back to you via a physical storage device. Let's say that you have 500 terabytes of data, and you need to get this 500 terabytes of data up on Amazon Web Services quickly. And your on-premise network doesn't have a strong enough data bandwidth pipe in order to handle this type of transfer. How might you go about getting that 500 gigs of data on Amazon Web Services, and then also all of the data that's been added since you shipped it? Well, the way that it would work is you take your 500 gigabytes of data, current as of the day that you take it. You put it on a storage device or multiple storage devices and ship it to Amazon Web Services. The next business day after receiving it, they will put it inside of either S3, EBS, or Glacier, depending on the job that you specify within the AWS interface. Then what you can do, since that data is already up there, if there's been any data that's been added to that 500 gig, you can then synchronize or replicate it from your on-premise to Amazon S3 because it already has that base 500 terabytes of data. So if there's only a few gigabytes of data transfer, you can then replicate it and then switch over to your AWS infrastructure. So this helps you to quickly get data from your on-premise to Amazon Web Services, and it also solves the problem of having so much data but not a big enough pipe in order to copy it up to AWS. So that concludes it for this lesson. Go ahead and complete this lesson.